Hello, welcome to the Chapter 6 review on exponential functions. We're going to get started with graphing. The first thing we're going to talk about are the points that you should be using as we graph problems 1 and 2. So the points that we're going to use are the same points we've been using. For my x value, I will be using -2, -1, 0, 1, and 2. And in just a moment, we'll get the y values. And that's going to be based off of the parent function. So the parent function is the base with its exponents, so 3 to the x power. And with 3 to the x power, I'm going to get my other points. So the one I always start off with is anything to a 0 power. Anything to a 0 power, including 3, is 1. 3 to the first power is 3. 3 to the second is 9. So notice as x is getting bigger, my y is getting bigger. This is exponential growth. Since this g is bigger than 1, this is growth. So right now, this is the shape that we will be focusing on because you got to know your shape. So anyway, I'm going to get the other points. So 3 to the negative first power is 1/3. 3 to the negative second power is 1/9. And one thing that we did talk about is there is a pattern, because if this goes 1, 3, 9 this way, then it goes 1, 3, 9 the other way. You just have 1s in the numerator and your 3 and 9 are a denominator. So now let's talk about the transformations. So anything that's been added to 3 to the x power is a transformation. So the negative is going to make it flip. This is my h. I'll take the opposite, so I should be seeing -1, and that's going to make it go left 1. And this is a minus. This will make it go down 1. So anytime I have a stretch or compress and a flip, I need to make a new column for my y's. So what's going to happen to all of these y's is the flip is going to make them all become the opposite. So I'll have -1/9, -1/3, -1, -3, and -9. And since it's flipping, this shape is going to flip. It's going to flip across the x-axis. So when I'm done, it's actually going to be looking like this. So again, know your shape and know what it looks like when it flips. So I'm going to graph my new points. I'm going to cross out the points I don't need, so the old y's, and then I'm not going to graph the fractions, so I'm just going to be sticking with these 3. So I'm going to graph 0, -1, 1, -3, and 2, -9. And then I'm going to take these points and move them all left 1 and down 1. So use a different color or mark it differently, but left 1, down 1, left 1, down 1, left 1, down 1. And the other thing that moves is my wall. Currently, my wall is right along the x-axis. It's right here. But it's not going to stay there. That wall is going to move down. It's going to move down 1 as well. So I'm going to go ahead and draw my wall. Okay? And I would recommend you draw on your wall. So here it goes. It was the x-axis, now it's moved down. And I can go ahead and answer this question over here for E, the equation of the asymptote. It is now y equals -1. You will have to state it's y equal. In the next chapter, we'll have a different type of wall, and it will be x equals. So this is y equals 1. All right, so I'm going to take these points and I'm going to connect them. So they're going to coast along the wall, get really close to it, never touch it, and then it's going to go down. All right, so now what I'm going to do is mark my arrows. So on the left, x is always -infinity. On the right, x is always infinity. Also on the right, it's going down, so y is going to -infinity. But on the left, you know, it is going up, and normally we would have put infinity, but it's going to get stopped at this wall of -1. So I'm going to put that there. All right, let's go to domain. Domain are the x's. My smallest x to biggest x is -infinity to infinity. You can use that, or you can say all real numbers. My range are the y's, so the smallest y I put in there is -infinity, and it went up to -1, and it is parentheses. And we talked about brackets include it. It means it actually gets to -1, and this is never going to get to -1, this shape. It's going to get close to it, but it will never get to it. And it will never cross it, so that's why we're going to use parentheses. All right, and behavior, so you got to set that all up. And you write the other one. All right, so for x is infinity, I should be looking right here. And when I put x is infinity, the y that I put was -infinity. And then for x is -infinity, I'm going to look here, and for y, I put -1. So for f of x, I'll be putting -1. And that's number 1 graphed. Okay, so again, the big thing on number one is g, what's attached to the exponent can never be a negative number. The negative means it has flipped, right? All right, number two. So first thing I'm going to do is go ahead and set up my points for x. Here are the same ones we're going to use. And now I'll make my parent function table. So the parent function comes from the base and the exponent. So I'll be doing 1/2 to the x power. So 1/2 to the 0 power is 1, 1/2 to the first power is 1/2, 1/2 to the second power means 1/2 times 1/2, which is 1/4. So as you can see, I'm dividing by 2. And then since g is 1/2, this is decay. This will be the shape. It's getting smaller and smaller. But going the other way, again, that pattern, if this is 1/2 and 1/4 this way, then on the other side, it's just 2 and 4. And again, the reason why, for instance, -1 gives you 2 is because if I take 1/2, I'm taking this whole thing to the negative first power. The negative says that the things move. So 1 will go to the bottom, 2 will go to the top, and then 2 to the first power is why I get this 2 over here. Okay? Anyway, let's go ahead and get the rest of the things. The transformations, this 2 is going to make it stretch. This 3 is going to make it go right 3, and this 2 is going to make it go up 2. So since I do have a stretch, I will be putting in a new y column, and I will take all my old y's and double them. So 4 doubled is 8, 2 doubled is 4, 1 doubled is 2, 1/2 doubled is 1, and 1/4 becomes 1/2. So I'm going to get rid of my old y's, and I won't graph those, but everything else will fit on my graph. So here's -2, 8, -1, 4, 0, 2, 1, 1. And again, you can see this shape that I've already drawn for you over here. It's starting to happen. All right, now what I'm going to do is take these points. They're going to go right 3 up 2. So I'm just counting over here on my graph, which is what you want to do. Everything goes right 3 up 2. And the last thing that will go right 3 up 2 is, one of these might be off. 1, 2, 3. This one's off. Is going to be my wall. My wall, which is y equals 0, which is technically the x-axis, will also go up 2. So my wall is about to move to here. Okay, and that is the equation y equals 2. It's not asked over in the A, B, C, D part, but I'll go ahead and put it. So now I'm going to connect my points. And again, I should see that decay shape. My points are getting smaller and smaller. All right, the domain. Let's go for our arrows now. So as far as domain goes, over here on the left, x is -infinity. On the right, x is infinity. On the right, it is going down, but it's going to hit that wall of 2. And on the left, it's going up and up and up, so we'll put infinity for y. So my domain, if you haven't figured this out yet, it is always all real numbers. But your range going up or down is limited by the wall, so my smallest y goes first, and then my biggest y, parentheses, and behavior. So this time as x is going to infinity, what's my y doing? So I'm going to look over here, and I put 2, so that's what I'm going to put here. And then again, as x is going to -infinity, I'm going to look here, and we put infinity. So that's what I'm going to write for f of x. F of x is going to infinity. This time I did put positive negative integral. This whole shape is positive. There's nothing negative about it. So if you want, you can just cross off the negative, underline the positive, but it's positive from the smallest x value, which is -infinity, to the biggest, which is infinity. And again, you could have written all real numbers there had you chosen. All right, number 3, we are going to be asking you, do you know if it's growth or decay? So this is all based off of y equals b times g to the x. So what we want to do is find the base when the exponent is x. So in this problem, here's my base and my exponent. So since g is 4 and that's bigger than 1, I'd be multiplying by 4 over and over and over again. So this is growth. How do I know? Because my g is bigger than 1. Now on the next one, when I look at my base and my exponent, what I end up having is all of this. Well, technically, the base is g to the x power. So if this is the x power right here, that's going to make all of this my g, and that's e to the third power. So remember, e is this number, and it's about 3. So when I take basically 3 to the third power, this is almost the same as 27 to the x power. Remember how we've been rewriting bases when we were solving? So it's kind of like that same idea. This g is now bigger than 1, so that's going to make this growth. It's really about 27. In the next one, so again, I'm going to look for my base and my exponent. Here it is. And again, it's g to the x power. So what I'm going to do is take that -3 away. There's the x, and then I need something here. So this is technically g, and then this is the x power. And so what's going to happen is it's going to take the negative exponent is going to move this e into the bottom. And so as soon as this is under 1, this is going to make it less than 1. Okay, like 1/2, 1/3, it doesn't matter. Technically, this is, if you really want to keep looking at it, this is about 3 to the 1/3 power. And you learned in Algebra 1 that a 1/3 power is like a cubed root. And the cubed root of 3 is a really small number. So it's 1 over this, it's going to be less than 1. So that's going to make this decay. And then on the last one, what I'm looking for, my g to the x power, here it is. G is 2/3, and since that's less, excuse me, that's supposed to be a 2, less than 1, that's going to make this decay. So the first two are growth, the last two are decay. All right, so kind of going off of this idea here, we're reworking the bases. That's what's going to happen here on number 4, 5, 6, and 7. We're going to solve, and when we solve, we need to find a common base. So this is where you would get your exponent table out, and you would look for a base that has both 16 and 4. So you have two options. You can use 2 or 4. I always go with the bigger one. So 4 to the second power is 16, and then I write the original exponent in parentheses, and 4 to the third power is 64. And then once those bases are the same, you can ignore them and you can focus on these exponents and just start to solve. So first what I would do is distribute. So then I'll have 6x equals 3, and then to get x alone, I'll divide, and I get 3/6, 1/2, 0.5, whichever you prefer. Number 5, when I'm looking for a common base, I'd be looking for 5. So 5 to the second is 25, and there's the original exponent in parentheses. And 5 to the third power is 125 with my original exponent. And now that those bases are the same, I can ignore them, and I can distribute. Well, let me rewrite it here. All right, so I will distribute, and I will get 6x, and then I will distribute here, and I will get 3x plus 3. And now I'm going to start solving. I'm going to bring the 3x over to the left side by subtracting, so that now gives me 3x on the left and 3 on the right. And once I divide by 3, I get my answer of 1. All right, number 6, what's the common base? So again, don't worry about the fraction. Focus on the 8 and the 64, and that common base is 8. So 8 to the second power is 64. There's the original exponent in parentheses. And 8 to the first power is 8, and the negative made it 1/8. So now that those are the same, ignore those bases. Focus on the exponents. With those parentheses, I'll distribute. So that's going to give me -1 equals a -6x. And then to get x alone, I need to divide by -6, and -1 over -6 is just 1/6 as your answer. Oops. All right, last problem. So on 7, the common base between 36, 216, and 6 is 6. So I'm going to take the first problem, and I'm going to rewrite that as 6 to the second power. There's the original exponent. 6, whoops, sorry, that's a times there. 6 to the third power is 216 with the original exponent. And 6 to the first is 6, and then the negative makes it an exponent. And now I want one base on the left side with the one base on the right. So what I'll have to do is look at, since these bases are the same and they're multiplying, I should add these exponents. So it should be 2x, that exponent, adding to the other exponent of 3 with the parentheses, and then that should equal the exponent on the right. So this video is going to pause, and you're going to go into the next one to finish up this problem.